Our project is on the production of biogas from biomass via anaerobic digestion. For the proposed project, we plan to transform the waste from an industrial tequila distillery into biomethane gas. Tequila distilleries employ the use of the blue agave plant to produce mass amounts of tequila per year. To put this into perspective, from January to May of 2018, according to the Consejo Regulador de Tequila, the agency that oversees tequila production in accordance with regulatory standards, 132 million liters of tequila was produced in the protected regions of Mexico. As you can see, the volumes of tequila being produced and the growth of tequila sales are consistently increasing with every passing year. This implies that the production as well as the demand for the product is also increasing every year. Because of this trend, we decided to implement a plant that produces biomethane from the waste accumulated from these tequila distilleries in Mexico employing the technique of anaerobic digestion. The inspiration of this proposal is derived from the current outlook on climate change and the use of fossil fuels versus renewable energy, such as biomethane. Our goal is to implement our recycle plant into the tequila distilleries in order to reduce their carbon footprint by the use of biomethane instead of fossil fuels.
There have also been other biomass to biomethane projects that include avocado stones, mango stones, and other agricultural materials as inputs to the process. The graph from a paper written by Pal Borgeson shows the average percent in reduction of greenhouse gases when petrol or diesel is replaced by biomethane. The use of a plant-based energy source reduces carbon dioxide emissions, which is why we ultimately chose blue agave as the process input. Blue agave uses a metabolic pathway that greatly reduces water loss and increases carbon dioxide intake called crassulaceous acid metabolism, or CAM. During CAM, the plant stores carbon dioxide absorbed at night and performs photosynthesis during the day. This means they can close their openings on their leaves during the heat of the day, saving a tremendous amount of water compared to other crops such as corn. It also allows for the use of higher levels of carbon dioxide than other crops like wheat, barley, and potatoes. During the anaerobic digestion, two species of cellulose-degrading bacteria will be used to break down the blue agave. Ruminococci, R. flavescens, and R. albus are found in the rumen of horses and cows that play a major contribution to plant cell wall breakdown in the large intestine. Based on the experimental data, the major chemical composition of the fibers in blue agave are 74.6% cellulose and 21.1% lignin. For our production plant, the inputs will be the ruminococci, acetic acid, and blue agave waste. The output for the process will be carbon dioxide, methane, and the solid waste of the soil conditioner. The agave waste will be brought in as a fibrous solid and be grinded into small particulates and heated up to be broken down further. Because our system is a batch system, the bacteria and acetic acid will be present in our reaction vessel. The blue agave particulates will be added to our reaction vessel for the cellulose to be degraded mostly into methane and carbon dioxide. The gas products will enter the scrubber in order to separate the methane and carbon dioxide. As for the solid liquid waste products, the solution will be separated in order to obtain soil conditioner that can be used when planting agave plants.
This is an example of a process flow diagram of our plant. Our design alternative 1 includes breaking the reaction into two reactors to produce methane, one reactor for the acid phase and one for the gas phase. A similar process can be used for the alternative design 2. Instead, the solvent used to dissolve cellulose could be changed to 1-allyl-3 methyl-limidazolium chloride and 1-ethyl-3-methyl-limidazolium acetate. The use of these strong ionic liquids allow for the cellulose to be broken down into its glucose compounds, which will require less bacteria to be used for the process. However, the cost of these solvents are extremely costly and are not viable for a profitable plant. Other successful processes have demonstrated the use of 4 reactors, one reactor for each step, of liquefaction, acidification, acetate formation, and methane formation. Potential challenges with these methods would be the cost of multiple reactors is very expensive, as well as the solvents and other components needed if the process was split up into parts. Operating at such high pressures is a safety concern and would need further research on how to operate at these conditions. Various types of inputs include corn, barley, wood, peanut shells, and wheat to be used as inputs as well. This, however, requires more solvents and bacteria due to the variety of chemical compositions for these compounds.
Some design considerations to take into account when building our anaerobic digestion plant are environmental impacts, social impacts, safety hazards, and their precautions. Some positive environmental impacts include reducing the greenhouse gas emissions, which mitigates environmental pollution, as well as the digestate being recycled and used as soil conditioner to provide the blue agave with a beneficial growing environment. Some negative environmental impacts include causing the rate of excess in crop demand of blue agave, as well as ammonia emissions and nitrate leaking of digestate if improperly stored. The main social impacts include changes of natural and agricultural landscapes while building our new plant next to the tequila distilleries, risk of pollution incidents, odors, intrusion of land, and the shredder being extremely loud. Some safety hazards that we need to consider are the biomethane, as well as the exhaust gas being produced, is combustible and corrosive, as well as the generation, transportation, and flaring of the biomethane can lead to oxygen deficient atmospheres, which can go hand in hand with the environmental impacts as well. The corrosive nature may also cause the equipment to break down, which would cause additional safety hazards to the operators on site. Some of the main precautions that need to be taken when building this plant is the use of corrosion-resistant material, as well as making sure the constituent materials being used in the digester are non-combustible. As for the equipment, the storage tanks must be equipped with safety valves to prevent excessive vacuum or pressure, and check valves need to be on the digester so there is no backflow of biomethane.
Based on an input blue agave waste of 11 tons per year, or 66,000 pounds per day, for an operational time of 333 days per year, an input of 66,000 pounds per day of acetic acid will be used as well in order to be used as a solvent. Because our agave plant is considered waste, it will not be considered a large purchase compared to our other costs. Also, because the bacteria will be grown in our plant, the bacteria and media will need to be purchased and grown before the process occurs. For acetic acid and bacteria waste, because it is considered a biohazard, it will have to be treated. Soil conditioner will be included when planting blue agave to maximize the waste of our system. Based on values from the Department of Energy of methane, we will have a profit of $151 million per year on an input-output level assessment. Assuming a 10% break-even capital cost, our total capital investment is $1.5 billion. Because our plant is a grassroots project, it seems viable and should continue.
We are claiming that our plant is viable due to the fact that building an anaerobic digestion biogas producing plant from the ground up would cost less than $1.5 billion.
In order to improve our assessment, much more research needs to be done for the equipment and utilities for our plant, including manufacturing, cost of labor, cost of installment, and other miscellaneous costs. Because our process occurs at high pressures and temperatures, the cost of these utilities will change our input-output level assessment. As for the impacts, the most important social impact includes changing the natural and agricultural landscapes to build our plant. This will directly affect the community and its people within close proximity of the production plant. As for the environmental impact, we are focused on reducing the carbon footprint of the tequila distillery. By implementing a recycle plant, we are reducing the use of fossil fuels, moving towards an environmentally friendly fuel source. Because we are creating solid waste in the process, it needs to be taken with extreme care to ensure no accidents occur in the plant.